Hi, everyone, and welcome to Backer Breaks It Down. In this episode, inverse functions, particularly evaluating inverse functions. So, what's an inverse function? Well, our little machine suggests it starts with the output and ends with the input, which is the opposite of what we know functions to do. Okay, so functions that are inverse functions are, first of all, denoted by this notation here, f -1. So it's not like f to the negative first power. That's, maybe think of the -1 as like a -I for inverse, why not? But that's the notation. And essentially what happens is it takes a function with a domain D and a range R and turns it into a function with domain R in range D. Right? Makes perfect sense, right? So we know that functions, the input is A and the output is B. Well, in an inverse function, the input is B and the output is A. I kind of like how my table kind of shows what's happening because like this is the notation we are accustomed to seeing. So we are accustomed to like what's on the inside of the parentheses is representing the input and what's on the outside is the output. So like X and Y. And an inverse function switches those things around, okay? So that when you see that inverse function notation and there's a value on the inside of the parentheses, that's an output value of the original function. And what's on the outside over here, that's an input value of the original function, okay? And so when you are evaluating functions and inverse functions, because you're going to see both of them like together, okay? Pay attention to, is it a regular function or is it an inverse function? So like really look for that little -1 indicating it's an inverse, okay? And so in these examples here, we are evaluating functions and inverse functions using a table of values, okay? So we have to pay attention to, is it a regular function or is it an inverse function? So in problem number 1, we have g of 0, right? So g of 0, that is a regular function, okay? Then we have to be like, well, what do we know? We know this is 0. That is the input. So I know that the input is 0. So what goes with the input of 0? Well, an input of 0 has an output value of 3. So that would be my answer. Okay. And problem number 2, g of question mark equals 0. So this is a regular function. What do we know? Well, it equals 0, so we know the output is 0. So find that in your table. Find the output of 0. Okay, so the value of our question mark here would be 4. And problem 3, g of 2. So this is a regular function notation. What do we know? Well, we know the input is 2. So find that on your table. Find the input of 2. So the corresponding output would be 1. And that's our answer. So in problem 4, we have g inverse of 0 equals question mark. So I am working with the inverse function. So what do I know? Well, they give me a number inside the parentheses. And the number inside the parentheses is an output. So I know that the output is 0. Find it on the table, output of 0. And the corresponding input would be 4. So the answer to number 4 is 4. Okay, These problems are simple, but you have to pay attention to, am I working with a function or an inverse function? Do I know an input value or an output value? Okay, that's what you have to like pay attention to. So in number 5, we are working with an inverse function. What do we know? Okay, so we know it equals 0. So 0 is representing an input value. So find an input of 0 on the table. So what's our answer here? 3. Question mark is 3. In number 6, we are working once again with an inverse function. What do we know? Inside number is 4. That's an output value. Find it on the table. Output value of 4. So our answer here is -1. Okay. So I can do problems like these using graphs as well. Okay, once again, pay attention. Function or inverse function. And then what do I know? Input value, output value. So in number 7, f of -2. This is a regular function. Okay, 2 is an input value. I'm sorry, -2 is an input value. So find that point on the graph that has -2 as the input or the x value. So it's right here. So when x is -2, the value of the function is 2. So compare that to an inverse problem. Okay, so notice how similar 7 and 8 look, but 8 is an inverse function. So what that means is that -2 this time is an output value. So it's a y value. So I can find where y equals -2, which is right here. And I see that the point on my graph is right here, right? So when the output value is -2, what's the input value? Yeah, the input value would be 0. Okay, so number 9, this is a regular function, right? F of 0. 0 is an input value. We want to find the corresponding output value. So find an input value of 0 on the graph, right here. Corresponding output would be -2. For problem 10, looks really similar to 9, but it's the inverse function. So that means this number 0 is an output value, right? So here is y equals 0. Find the point on the graph. So when the output value is 0, what's the input value? -1. So I can do these problems, evaluating inverses and functions. We can do that with function formulas as well. It's just a matter of, once again, pay attention, function or inverse function. And then what do I know? Input value or output value. So in 11 through 13, we're working with a function 3x plus 1. Find the following. So number 11, I have f of -1. That's right, this is regular function notation. So that means this -1 is an input value. So you know what that means. Put it into the function. So 3 times -1 plus 1. Yeah, we're looking at what? -2. In problem number 12, we have f inverse of -1. So in problem 12, we are working with an inverse function. The -1 inside the parentheses, that's an output value. Okay. So an output value goes on the outside of the function. So we have the function 3x plus 1 equals our output value of -1. And then I'm simply solving an equation. So I get x is -2/3. And then 13 is essentially the same as 12. We're working once again with an inverse function. This 13 here is an output, so it goes on the outside of the function. So 3x plus 1 equals 13. And then we solve for x. Okay. So the key to evaluating inverse functions, well, to evaluating functions and inverse functions is to first pay attention. Is it a function or is it an inverse function? Remember, inverse functions have that little -1 indicating it's an inverse function. Okay, and then ask yourself, what do I know? Do I know the input value or do I know the output value? And then find the corresponding value. And that's how Backer breaks it down.